This lesson's about a method called the product rule, which helps us to differentiate more complex functions with respect to x. So if I was given a function and I was told that y equals u times v, and we know that u is a function of x and that v is a function of x, then we can find the derivative of y with respect to x by looking at this expression here, which says dy dx is equal to the original function of x, that is u, times the original function of x, that is v, times the derivative of the function of x that was u, plus the original function u times the derivative of the function of x that was v. And all of that sounds rather complex and confusing, but it's really quite straightforward. So how about we get stuck into an example? And what I'll do is use one straight from the textbook. So if we have something like this, for instance, which looks pretty hideous, but if I say that y equals x cubed plus 5x squared minus 3, and that's going to multiply x squared plus 1 all squared. Actually, no, we're going to make that to the power of 5. Alright, what we actually have here is two functions of x, this one here and this one here, and we want to be able to find a derivative. So what we do is we label the first function u and the second function v. Okay, and over on the side here we'll find that we'll write down that u is equal to, actually give myself a bit more space here, u is equal to x cubed plus 5x squared minus 3, and the derivative of u with respect to x will equal 3x squared, oh, that's being a bit uncooperative, plus 10x. Right? And then if I look at v is the function x squared plus 1 all raised to the power of 5, and if I find the derivative of v dash or v prime, we take the derivative of what's inside the brackets first of all, and that will give us 2x. We bring down the power that was there originally, that comes down the front, so that gives us a 5. And then we have the original brackets, x squared plus 1 to the power of 4. That can be summarized to be 10x outside of x squared plus 1 to the power of 4. Alright, now looking at the algorithm that we've got for finding the derivative of y, that's y, with respect to x, what we'll find is that y prime, the derivative of y, will equal the original function of u, that's this one here, that's the original function, so that will be x squared plus 1 to the power of 5 times the derivative of u, that's this one here, so it times the derivative of u, which is 3x squared. There should have been a squared over there, which I neglected to put in. 3x squared plus 10x. Then we add the original function u, which is this one here. So we'll put x cubed plus 5x cubed, 5x squared minus 3 times the derivative of v, which is this one here, and that will be 10x x squared plus 1 in brackets to the power of 4. That is actually the derivative. Now, what we would probably typically do is try and tidy that up a bit, but it's not really necessary. The truth is that would be the derivative of the function. And we would leave it like that. Let's try another example. Here's one. It's a little bit different. We've got 5x plus 3 all over 2x minus 1. Right, now, the initial problem we've got is that this is a division, it's not a product. So we're going to change that to make it become a division. So we'll have 5x plus 3, and if you stop and think about it, everything that's in the denominator of this fraction can be written as a product 2x minus 1 to the power of minus 1. And now those two expressions are equivalent. And we'll set the first part to be u, the second part to be v. Over here we'll say that u equals 5x plus 3. So the derivative of u with respect to x will be 5. V is equal to 2x minus 1 to the power of minus 1. And v dash, or v prime, will be equal to we take the derivative of what's inside the brackets. That'll be a 2. Oopsies. That will be a 2 times the power comes down, so we've got minus 1. And then in the brackets we'll have 2x minus 1, and the power will be minus 2. And when we put all of this together, just remind you that if y is equal to that function, then y dash will be equal to v u dash plus u v dash, and the function v is 2x minus 1 to the power of minus 1, and u dash is times 5 plus the original function u, which is 5x plus 3, times the derivative of v, which will be minus 2 times 2x minus 1 to the power of minus 2. Alright, and now if we write that a little bit more neatly, that'll give us 5 over 2x minus 1 plus minus 2 outside of 5x plus 3 all over 2x minus 1 squared. Okay, and we can actually bring those two things together by giving them a common denominator, in which case this denominator here will be what we're looking for, and we can make the first denominator the same if we multiply it by 2x minus 1. So that will give us 5 outside of 2x minus 1 all over 2x minus 1 squared minus 2 outside of 5x plus 3. And if you expand that and then simplify, you can tidy that up even further, and you'll find that the first set of brackets gives you 10x minus 5. The second set of brackets gives you minus 10x minus 6, So we should end up having a minus 11 over 2x minus 1 to the power of 2. Alright, a couple of examples there of how to apply the product rule, and now it's time for you to go and get some practice.